Okay, so good morning, guys. Let's get started with our notes on 1.6, which deal with inverse functions. So inverse functions switch all the x and y values. That is essentially all that's happening. So if I was to create a table with my function of x, y values, each x and y value would just flip around. So for a function to have an inverse, that means it should be 1 to 1. Each x goes to a unique y value. That means no y's are repeated. So we talked about the vertical line test to see if something is a function. There's actually a horizontal line test to see if a function has an inverse. Horizontal line test works just like the vertical line test, except now it's horizontal. And so if it touches a function more than once, that means that it technically does not have an inverse. So that is our vocabulary. And let's take a look at how this works. Okay. A function f is defined by the set of ordered pairs to form the inverse function of f. All we have to do is switch the x and y values. So like I said, just about switching them around. So we will use this f to the -1 to represent inverse. So for a function that it's inverse, the domain of f now becomes the range of f inverse. The range of our original function now becomes the domain. So I know we've done a good amount of talking about domain and range. It is important, but I want to kind of get into the heart of this. So to verify two functions are inverses, we're going to compose them. If we do f of g of x and we end up getting just x in the end, and when we do g of f of x, we get just x in the end, they are inverses. If we compose them and get anything except for x, they are not inverses. I'm going to show what that means graphically, and I'm going to first show it algebraically. So verify that these are inverses of each other. So I'm going to do f of g of x, then g of f of x. So do that one in red, this one in green. So I'm going to start f of g of x. So f starts out with 2, then it has x. Where I have x, I'm going to plug in g of x. And then just keep it going, -3. So all I did here was plugged in what f of x is, or sorry, what g of x is into f of x. So now I'm just going to do my math here. If I do 2 times this, so there's a 2 in the denominator, those easily cancel out, giving me x plus 3 minus 3. Well, -3 and a +3 end up being, get some people coming in. Okay, I think I hit emit on them. Awesome. A +3 and a -3, they cancel out, so that just becomes x. So we got that first condition satisfied. F of g of x is equal to x. So there, it's looking good that these are inverses. I just want to check it the other way now. So now I'm going to do g of f of x. So here with this starts with x plus 3. So right away, in the very beginning of it, where it has x, I'm going to plug in 2x minus 3. It says plus 3 all over 2. Well, again, a minus 3 and a plus 3 is just 0, so that gives me 2x divided by 2. 2 divided by 2 is just 1. So again, we get x here. So we can say these are inverses. So there we go. Do we have any questions on this algebraically? Okay. So let's take a look at this graphically. So what I'm going to do is I am just going to type in these functions, f of x and g of x, just how they are. So f of x is equal to 2x, that one was minus 3. Okay, so that's that function in red. Then g of x is equal to, what was that, x plus, x plus 3 divided by 2. So we see that in red and blue. These are inverses of each other because they are reflected over the line y equals x. What would you say? No, it would. Yeah, it will work if we switch the order around. Not a big deal. So here with this, I physically see it looks like the blue line would be reflected over the green to get the red. Now watch this. If I do f of g of x, all of a sudden the purple line went where the green was. That's y equals x. So since it goes where y equals x is, that means that y composed and we just get x. That's the same thing I just showed algebraically right here. If I compose it the other way, g of f of x, again, now it's making that line black. So we can see whether I turn them on or off. So that's the line y equals x in green. F of x, f of g of x, sorry, is purple. It's that same line. G of f of x is black, and it's that same line as well. So that's a way we can visually and graphically confirm that they're inverses as well. Okay, so let's continue on. So if a point A comma B falls on f of x, that means the point B comma A is on the inverse, and it is reflected over the line y equals x. So that's just what I was talking about, that reflecting over the line y equals x. If it's reflected over that line, they are inverses. So a function is 1-to-1. If a function is 1-to-1, that means each x value goes to a unique y value. So y values do not get repeated. A function f has an inverse if and only if it is 1-to-1. So what we end up using is the horizontal line test. So if a horizontal line crosses a function more than once, it is not 1-to-1. Therefore, it does not have a formal inverse. Okay. So does this function right here have an inverse? So we're going to use, again, the horizontal line test. So this works just like the vertical line test. It touched it at more than 1 point. This actually touches it at 3. So does it have an inverse? No. It fails the horizontal line test. So you guys did well with the vertical line test. It sees something was a function or not. Horizontal line test is the exact same idea, just with a horizontal line now. Let's now take a look at how to find an inverse. We figured out how to say if two things are inverses, but how do we actually figure out what the inverse is? So first step, use the horizontal line test just to make sure we can find an inverse. What we're going to do is replace f of x with y. Then I'm going to switch my x and my y values. So switch x and y, then we're going to solve for y, and then replace that with f negative 1. So let's keep these dual screen display. There we go. This way I can keep the steps right next to it with finding the inverse of this. So right away, this is a linear function, which is automatically going to be 1-to-1. So I know it passes the horizontal line test. So first step just says replace f of x with y. So I just start writing this y equals 4x minus 5. First step, super easy. Next step, switch x and y. So now I'm going to write it as x equals 4y minus 5. That was a little sloppy. So all I did was rewrite the equation. Where I saw x, I changed it to y. Where I saw y, I changed it to x. Now our goal is to solve for y. So I can start by getting rid of this minus 5 with a plus 5. That's going to give me x plus 5 is equal to 4y. Now I got that 4 in front of the y. I'm going to divide the whole thing by 4. So I'm just going to make this one big fraction back here. So whenever I'm dividing like that, I'm just going to leave it a big fraction. I don't mind, I don't care. That's fine to leave it like that. Now the final part is actually not too bad. All it says is replace y with f inverse. So I could just write it as f inverse of x is equal to x plus 5 over 4. So that's how I do that algebraically. Do we have any questions on that before I confirm that these are inverses with Desmos? Cool. Okay, so what I'm going to do is I'm going to call f of x, the function I started with, g of x, the second one. I'm going to see it goes over that line, y equals x, and see, I'm going to turn those off for right now. So let me just edit this to be f of x was 4x minus 5. So right now, the red and the blue definitely aren't inverses of each other because they're not reflected over the line y equals x. But g of x was an old function in there, so I know that was not right. That was plus 5 over 4. So now that I have those as the two functions I was given, now they're looking like they're reflected over the green line. And again, I have f of g of x. Let's see if purple shows up as, yep, the line y equals x. Let's check if g of f of x, the black line, yep, they're all that. When I compose them, Desmos is showing them it's the line y equals x. So they are inverses. So that is it for this. So our homework is 20 through 24 even in this section, and then 72 through 78 even. Please give those problems a try. We do have a little bit of time left today. You could get a little bit of a head start on them. If you have questions on any of our homework, tomorrow's a day we're saving to take advantage of that, / give you time to work and answer questions live. So please make sure you do that. If you have questions, stop the recording as we have covered what we need to cover. So thank you guys. If we have questions, just let me know. Stop recording.